All right, here we go. First thing is this zero, the last zero. It has to be the product of 5 and an even digit. And that 5 can go in one of two places. We don't know which one is going to go in, but for the time being, let's try it there. Now, since this number is 5 times a 3-digit number is still 3 digits, the first of those digits must be 1. Since this is 100 something times a digit, then some more digits must be 1s. I guess this digit over here has to be a 1 also. There's no way those things can add up to 200,000. All right. Now, since this 1 and this digit and whatever this adds up to carry, then this digit has to be at least an 8. I'm gonna Is there something weird about this? So apparently these things aren't pure white, so I can't flood fill the boxes to make them obvious to you. Anyway. That one. That one has to be at least an 8. So that means that the second digit after the 1 at the top has to be at least a 6. Now, actually, that's not quite enough, because if this is 162, no, if this is, what the heck number would that be? Yeah, 162, and this would be 810. The next number above it could be is 15. And yeah, 81, 15, and 1 is 98. That's not quite enough. If we make so what is enough? 164, 820, and 15 is still not enough. Oh, actually, we know more than this. Yes. So Math Grant has pointed out in the chat that, well, maybe not exactly what he was thinking, but because squares aren't 0, this second box down here has to be at least a 1. And since there's no way you can make it be more than a 1, we'll make it be exactly a 1. That means that our squared box has to be a 9. And then we have a carry from the other column. So now we have to have at least 1/8 something in the top row. And maybe 1/9 in order to get a carry. Well, no. If this is 1/8 something, and this is 1/7 in this row, from 1/8 something multiplied by 9, then we have 18. We need this to be at least a 3 in order to avoid a 0 at the bottom. So we need to have at least 186 at the top. Oh, there's some more things I can fill in, actually. We know these zeros can't sum to a 0 because it says squares aren't 0. And we can only possibly have one carry. So we have a 1 there. We're starting to get to the point where we can just say, well, what multiple of one of these numbers has this pattern? But let's try to solve it for real. Oh, we have another. Yes, Grant is pointing out the possibilities of filling in these first two partial products. These other two digits in the 5 here have to be at least 6, since they're larger than the 900 something at the bottom. And 6 times 186 is already more than 1100. So we can't do it. So this means that my initial assumption that the 5 goes there was wrong. And that's why we have the undo key. So the 5 has to go over here. And we have to do this the hard way. Well, maybe it's not the hard way. Maybe it'll actually be easier this way. Because now we know these other two partial products are going to end in 5s. We will bring a 5 down here. We still have a 1 in a couple of places. Here. Here. Yes, this product ends. The first partial product ends with a 6, 5, 7, 5, 8, 5, or 9, 5, which gives us too many possibilities to kind of sort through at this point. Now, we know this first digit is even, so it's at least 2, and 2 times this first number gives us something that's still 3 digits. So, we know the first digit of this product is a 4 or less. And let's see. All right. This is tough. Oh, Grant has solved the combinations that end in O5. Given that we know um, we have an odd digit times some digit and 5. If we had 5 times some digit and 5, it wouldn't work out because we'd always end up with 2 5 or 7 5 at the end. If we had a 1, we just repeat the same 2 digits, and we can't have a 0. If we have a 3, we get 15, and then we need to have another 3 to make a 9 to give this 0. If we have a 7, we have 35, and we need a 1 to make a 7 to make the 0. And if we have 9, we have 45, and we need a 4 to make 36 to give the 0. So, I suppose I'll just start plugging in these possibilities and seeing what happens. So we're going with the 3 and the 3 because it's the smallest of the numbers, and it seems like worth trying first. Oh, I put that in the wrong place. It's supposed to be a 3 here and a 3 here. Now, if it is a 3, we need the digit before it has to be smaller, since it makes a 3-digit product and the other one makes a 4. That means that we have to have a 1 in this first box. And we filled in the whole... oh no, not a 1. We need to have a 1 in this first box. And therefore we have to have a 3 or 4 in the first box, but a 3 would give us only 1,005. It needs to be more than that, so it has to be a 4. So 1305. The bottom row is 870. Does this look like something that's going to work out? This digit will copy down here, whatever it is, and we'll carry 1, and we'll get 8, 9, 10, and we'll get a 0 here where we're not allowed it. So, no. Not 3, 3. So let's try, the next possibility is a 7 times something ending in 15. Now, in this case, our possibility